Hi, this is Maggie. In this video we're going to look at how to desk check and debug a program with functions. This video assumes that you already know how to desk check and how to use the idle debugger. So if those tools are unfamiliar to you, you should review the sections of the textbook that go through them, or review prior desk checking and debugging videos. And of course, this video also assumes that you're familiar with functions, including parameter passing, returning values, and variable scope.
Before we get started, I'm going to quickly give you some tips for how to get the most out of this video. First, if you have problem solving with Python, read up through Chapter 5. If you don't have it, you can still learn a lot from this video. Open up idle and follow along with Python as I work. Sometimes I'm going to suggest you pause the video and complete some steps on your own. When I do that, pause the video and do your best to complete the steps on your own. The way to learn to program is by programming. You can watch and learn if you work along with me. Remember, you can always pause the video and try something, or go back and watch again. You don't have to wait for me to tell you to pause. There are some automated exercises in the description of this video. The exercises work with the same code or similar code to the code in the video. After you've completed the video, try the exercises to cement the concepts in your mind. Now let's get started.
We will debug this program called predictracetime.py. Now sometimes people like to run in road races like 5Ks, 10Ks, or even half marathons or marathons. They might train for a longer race and compete in a few shorter races while they train. Sometimes with a longer race, when you register, you need to enter the pace that you're going to run. You're then put in a corral at the start of the race, and the start times are staggered so there aren't slower people, like me, clogging up the front of the race, and so the race is nice and spread out and everybody has space to run. A runner can use a race time predictor to find out roughly how long it will take them to complete a longer race if they've already completed a shorter race, so they can enter that pace accurately when they register. So if I run a 10K in 70 minutes, a race time predictor might predict around 157 minutes for a half marathon, using the runner's world formula that our program uses. So let's look the program over. The program has 3 functions, all defined at the module level of the script, which means they're all visible to each other. I can call any of them from within the module. The first executable line of code in the module is the call to main here at the bottom. All of the functions are defined above this call. So execution will begin at main. Let's take a look at it. In main, we have some local variables annotated. We then invoke the getPositiveValue function 3 times. It returns a result. We can tell because it's on the right-hand side of assignment statements, and we're assigning the results into the variables time1, distance 1, and distance 2. We then pass those values to a function called predictTime, and we get back again, because predictTime is on the right side of an assignment statement, a value that is stored in time2. Then there's a print statement that prints out this calculated result. Now if we look up at getPositiveValue, notice it takes a formal parameter called prompt, and it obtains an input from the user until they give a positive value, and then it returns that value. And if we look at predictTime, we can see it takes 3 numeric formal parameters, it does a calculation, and it returns the result of the calculation. In both of these functions, there are some local variables defined. Value in getPositiveValue and T2 in predictTime. Let's run this once to see how it works, and then we'll run it start to finish in the debugger. So it prompts me, the user, for the number of seconds for the short distance. Let's say I've run a 5K and it took me 30 minutes, which is 1800 seconds. It asks what is the short distance. I'll use kilometers for my units for both races, so I'll say 5. It doesn't matter what units I use as long as I'm consistent. Now it asks me what the long distance is, so suppose I have my sights set on a 10K. I'll put in 10. And it predicts the 10K is going to take me 3,816 seconds, which divided by 60 is approximately 64 minutes. Okay, I'll start the debugger now and check my source box and rearrange my windows so I can easily enter input at the console and see my code and the values in the debugger. And I'll run my program again, and I'll start with over, but we're going to be using the step button sometimes too. Now notice that as I click over, it stops on each function definition, but does not go into the function bodies. The functions are defined so that they can be used later. You can see the defined functions down in the locals area in the debugger. We see get positive value, main, and predict time. These are names that are within scope. They can be used. We can invoke these functions. Okay, but now we're on the call to main at the bottom. Now here's the difference between the step button and the over button. The step button will go into a function if we're about to execute a function call, and the over button will execute the function call without stepping through every line of code. We want to use step if we've written the function and we want to go in and see how it's working, especially if we suspect it isn't working the way we thought it would. We want to use over if it's a function that's part of Python or a library, because we didn't write that code and it will probably be confusing to step through it. Now eventually, as you get more confident as a programmer, it might be cool to look at that code that's part of the Python libraries. But for now, step into your code and step over Python code. So we're going to click step so we go into main. And I'm immediately on the first executable line of main, which is time1 equals get positive value, and I'm passing in the string how many seconds to complete the short distance. Let's click step because we wrote get positive value and we want to see that function execute. And execution jumps to the first executable line of get positive value. Now let's take a moment here to look at the debugger window. This box in the middle is the stack, which shows me the order of function calls that got us to where we are. And we can see in module main, and that means the file or script itself, line 43, the function call main. And then from there, within the function main, so main.main, on line 32, the call to get positive value. And then the function main.getPositiveValue, line 11. And that's the line that's executing right now. We can also see, down in locals, that the parameter prompt has the value how many seconds to complete the short distance, which is the value of the actual parameter, the value we passed in when we invoked this function. Okay, so let's click over, because this is an input statement and we don't want to see the Python code for input. And in the console, we get the prompt. Let's use the values from before. I'll write 1800, the number of seconds to complete the short distance. That gets stored in value, which I can see down in locals in the debugger. And there's an input validation loop to make sure the user enters a positive value while not value greater than 0. But that test will be false because 1800 is greater than 0. So when we press over, we jump over that conditional code to the last line, return value. And this is where we will pop this frame off the call stack. We will leave this function, main.getPositiveValue, and we'll go back to where it was called from main.main line 32. Let's press over. So you can see in the stack that we are back in main, now on line 33. We can see in locals that the value that was returned from getPositiveValue, 1800, is now stored in the variable on the left side of the assignment statement, time1. Line 33 is another call to getPositiveValue. Each time we call getPositiveValue, we're starting over from scratch with that function. Let's use the step button and go into this execution as well. I click step, and you can see from the call stack that we're in getPositiveValue, and we can see the value of the parameter prompt, but this time it's what is the short distance, so that's what we passed in when we invoked it on line 33. Notice that we can't see the local variable from main, time1, that variable is out of scope within getPositiveValue because it is a local variable defined in main. Let's enter 5 now at the prompt. For 5k, we can see that 5.0 is stored in value, and then we press over until we return. And we're back in main on line 34 now, with 1800 stored in time 1 and 5.0 stored in distance 1. So now we can see those local variables to the function main, but we can no longer see the local variables for getPositiveValue. They're gone for good because we already returned from that function. Let's step over the third call to getPositiveValue, as we've already stepped through that function twice. I'm prompted for the long distance, and I'll enter 10 for 10k, and then we return, and now there's a value in distance 2 in main, 10. Now we're on line 37 in main, time 2 equals predict time 1, distance 1, distance 2. So we can step into this function, and now you can see we're in predict time on line 21, the first executable line, and we have local variables, parameter variables, T1, D1, and D2. I purposely gave these unique names, even though they're not great names because they're abbreviations, to make it clear that these are not the variables from main. These are the parameter variables, and they are local to predict time. They have the values that were passed in from main. And we're calculating T2, which comes out to 3,816. And when we return, that is stored, you can see, in the variable time2 back in main. And now we're at the output line, and we press over because we don't want to step in that Python print statement code. And the program displays the predicted time to run 10.0 is 3,816.0 seconds. And then we have run out of code in main, so the program is done executing. The main function does not have a return statement here, but it will return when there is no more code to execute. So what should you take away from this debugging about flow of control and scope in a program with functions? Take away that functions execute only when they're invoked, not when they're defined. We can invoke functions as many times as we need to. Pay close attention to the order of parameters, because actual parameter or argument values are copied into formal parameters by the order of parameters, not the name. Formal parameters are local variables, which means they exist only while a function is executing. Local variables defined within a function also only exist while a function is executing. You can't access local variables outside of the function's scope. If a function needs a value to operate, you have to pass it in as a parameter. If a function produces something that is needed by the calling function, you must return it. And back in the calling function, you must assign it into a variable, or the value will be lost. When we invoke a function, we jump into that function's code and execute it until either a return statement or until that function no longer has any code to execute, according to the flow of control. Each function has names that are visible from within its scope, and that includes names defined within the function, such as parameter values and local variables, and names that are defined in its enclosing scope. In this example, the module scope is the enclosing scope for all of these functions, and the names defined in the module scope are these functions, so we can invoke any of these functions from within any other functions, or within the module itself. Notice we invoke main from within the module itself, and we invoke the other two functions from within main. Now suppose we want to desk check a program with functions. How do we do that? One thing you might have noticed is that the variables that are in scope change when we change scope. So for example, when we're desk checking the main function, we can see the variables time1, time2, distance1, and distance2 once each is defined. But when we're desk checking the getPositiveValue function, we can see none of those variables. We can see only the local variables prompt and value once defined. There are also a lot more variables once we have a longer program with many functions. One approach you could take is to create a separate desk checking table for each function. Another is to create one desk checking table but block out variables that are not in scope and therefore not visible when you're executing lines of code in a different scope. We'll take the second approach, creating one very large desk checking table for this program. Here's how I've set up the desk checking table for this program. I have in the first row the heading line number, and then each of the function names and input and output. And in the second row, I have a second set of headings, and that's the variables that are defined within each function. So for main, for example, I have time1, time2, distance1, and distance2. And for getPositiveValue, I have prompt and value. Notice I also have a column labeled return for this function, which is where I'm going to put the value being returned by the function. I don't have a column like that for main because the main function doesn't return anything. This is going to be a really helpful column to include for all functions that return a value. So I also have a return column for the predict time function. Okay, so let's begin desk checking the program. I've opened it in Notepad++, so I have line numbers. And remember from running the debugger that each function will be defined within the module scope as we proceed sequentially through the file. So I won't write that in the desk checking table, but it's important to understand. The functions getPositiveValue, predictTime, and main are all defined so they can be invoked from any code that is within the module scope. We finally get to the first executable line of code on line 43, and that is the call to main. So I just write in my table that line 43 executes. But on that line, we can see none of these variables. They're all out of scope because we are not in any of these functions. I'm going to shade those cells in the table gray just to be completely clear that those variables are not visible on this line of code. Okay, and from there we go into main, and the first executable line of code in main is line 32, because before that we have a docstring, variable annotations, and a comment. On line 32, we're invoking the function getPositiveValue, and we're passing in a literal string, how many seconds to complete the short distance. So we jump to the first executable line of getPositiveValue, line 11. Now on this line, the variable prompt has a value, because it's a parameter variable, and it has the value that was passed in, the literal string, how many seconds to complete the short distance. I have abbreviated that in the desk checking table to save space. Notice also that in each function, I have grayed out the variables in other functions that are out of scope and therefore not visible within the current function. So in getPositiveValue, I can only see or use in my lines of code variables in this function. Line 11 is an input statement, so the program will display the prompt and obtain a value from the user. I'll put the prompt in my output column, and we'll need to come up with some values for the user to enter for the purpose of our desk checking. Let's imagine that the user has run a 10K in an hour, or 3,600 seconds. So the user will enter 3,600, and this will be converted to a float and stored in value as a float. The next line to execute is line 12. I did not put a condition in my table because I didn't have enough space, but it can be very helpful to put conditions in your table. In this case, the condition not value greater than 0 is false, so we will not proceed into the conditional loop code on lines 13 and 14. So we'll proceed to line 15, return value. On line 15, I have put the value that is returned, 3,600, in the return column. Now we go back to the line of code on which we invoked this function, line 32. The function invocation, getPositiveValue, how many seconds to complete the short distance, evaluates to the return value, 3,600, becoming the right side of this assignment statement. So on line 32, now that we have returned from the function, the value 3,600 is assigned to the variable time1. Now we proceed sequentially to line 33, which is another function invocation. The same function, getPositiveValue, but this time we pass in the parameter, what is the short distance? And you might consider pausing the video and seeing if you can complete this part of the desk checking table, because it's going to be very similar to what we just did, except the value in prompt will be different because we've passed in a different value. The user should enter 6.2 here, which is the number of miles in a 10K, because I'm going to use miles as the unit here and not kilometers. Okay, so let's compare, if you did pause and desk check, to what I have. We jump to line 11 which is the first executable line of the function getPositiveValue, and we have a value for prompt, which is what is the short distance, which I've abbreviated here. This line is an input statement, so output is what is the short distance, and input is 6.2, which is stored in the variable value. We then execute the test on line 12, and that is not 6.2 greater than 0, which evaluates to false, so we skip the conditional loop code and jump to line 15, the return statement. The value we're returning is the value stored in the variable value, 6.2. And we return to the line on which we invoked getPositiveValue, line 33, and the function invocation evaluates to the value that was returned from the function, 6.2, and that is stored in distance 1. Now look at line 34. Again, we're going to invoke getPositiveValue. See if you can pause the video and desk check that, and return and compare to my result. This prompt is asking for the long distance, and let's imagine we've run the 10K, or 6.2 miles, and we're hoping to run a half marathon, or 13.1 miles. So that's the long distance, 13.1 miles. Okay, and here's my desk check of the third invocation of getPositiveValue. Again, I did not have the user enter any invalid data, so they are presented with the prompt on line 11, type in 13.1, which gets stored in value, and the test on line 12 is false, so we execute line 15, the return statement, and return 13.1. Back in main, back to line 34, where the function was invoked, the return value is stored in the variable on the left side of the assignment statement, distance 2. Now, you might wonder why I'm leaving the values in main when I'm desk checking the function getPositiveValue, but I've grayed them out. But when I'm done executing getPositiveValue, I erase the values in the variables. There's a reason for that. The function main is still on the call stack when getPositiveValue is called. In other words, main is running, and then it calls getPositiveValue, and we're going to return to main. So Python has to remember all of the variable values in main because we're returning there. But when we return from getPositiveValue, it's done executing, and we're not returning to that invocation. We might call it again, but that's a separate invocation. When we return, it is wiped off the call stack. So main has not finished executing. We haven't returned from it. So we leave the variables because we're coming back to them and we need them to still be there. But getPositiveValue is done executing and will therefore be erased from the call stack. We're not going back. We might go again in a separate call, but we're not calling another function from getPositiveValue and then returning to the same invocation as we are with main. And so, still in main, we just executed line 34, and the next executable line of code is line 37. And this is another function invocation, this time to predict time, and this time we're passing in 3 values in this order: time 1, distance 1, distance 2. So from line 37, we jump to the first executable line of predict time, which is line 21. Now we have 3 formal parameters, T1, D1, and D2. The values that were passed as actual parameters, or arguments, are copied in order into these variables. So time 1 was the first parameter with a value of 3600, and 3600 is copied into T1. The second actual parameter was distance 1 with a value of 6.2, and that will be copied into the second formal parameter, D1. And the third actual parameter is distance 2 with a value of 13.1, and that will be copied into the formal parameter, D2. And on line 21, we are performing a calculation with the values in these parameters, 3600 times 1.06 times 13.1 divided by 6.2. And if I calculate that using idle tells me 8062 let's round that to 0.8. That value is stored in the variable on the left of the assignment statement, T2. And then on line 22, we have a return statement, and the value being returned is the value in T2, 8062.8. We return to the line on which this function was invoked, line 37, and the function call evaluates to the return value, 8062.8, and that is then stored in the variable on the left of the assignment statement, time 2. So notice that there's no way I can access that return value unless I assign it to a variable here in main. The variables that were part of predict time are gone once it returns, but I do have that opportunity of returning a value and assigning it to a variable in the calling function if I need that result. Usually a function does produce a result that you need back where you're calling the function. So back in main, we have only one executable line of code left, spread across lines 40 and 41, and that is a print statement that prints a string with interpolated values from the variables distance 2, which is 13.1, and time 2, which is 8062.8, and that is the predicted time to run 13.1 is 8062.8 seconds. That is the output on line 40/41. And finally, we are finished executing main, and we return to the line of code where main was invoked, line 43. The function main returns no values, and there is no code after this line, so we're done. And now, finally, main is wiped off the call stack, and those variables no longer exist. I do recommend stepping through by hand or desk checking this program a few more times with different values. Try entering bad values so you can execute the loop in function getPositiveValue, and then step through the program in the debugger to check your work.